Let's finish up neurotransmitters. Start here with a little quiz. How are we doing so far? Serotonin is a what? Catecholamine or indolamine? And it can be inactivated how? By MAO, COMT, or both? What's true for serotonin? What kind of neurotransmitter is it? And what can inactivate it? Yeah, it's an indolamine, along with melatonin. And MAO, remember, inactivates all the monoamines, so it will inactivate serotonin as well. So histamine. You've heard of histamine before, at least in the form of an antihistamine, which I'll bet you've taken at one time or another. So histamine, another monoamine synthesized from histidine, so as long as you're eating food, you're getting that. It's extremely important in the immune system, so we talk about it a lot in Bio 202. Released by basophils and mast cells, which are types of white blood cells, acts as a very powerful vasodilator. So, for example, whenever you get an injury like a cut or something on your arm, you know how you get inflammation? Inflammation is caused in large part by the release of histamine. Histamine vasodilates. Why would you want vasodilation when you have an injury? Well, if like your tissue has been injured, then you need to bring white blood cells to fight the invaders that got in, and you need to bring nutrients to do the repair. So it makes sense. Normally when you have some kind of an injury, you go ahead and release histamine, which vasodilates, get more blood to the area, and now you can fight off the bad guys and repair the tissue. Also involved in allergy symptoms such as itching, sneezing, coughing, red eyes, hives, etc. Those are all actually part of your immune system. So when you get a cold, a cold is a virus, I'm sure you know, but it's not the cold virus that causes all the sneezing and coughing and all that kind of stuff, and your nose running and your eyes turning red. That's your immune system doing that. Think about it. If you've got a virus in you, a cold virus, it's in your respiratory passageways, your body's trying to get it out. So how do you get it out? You sneeze, you cough, your nose runs, your eyes turn red. Again, bring more blood to the area, bring more histamine, vasodilate, water leaks out. So, so it makes sense. Histamine involved in all those kinds of things. That's part of your immune system's response. It's trying to make you better. The problem is you hate it, don't you? You hate the sneezing, the coughing, and the scratchy throat, and the itchy throat, and all that stuff. So what do? You take antihistamines in order to make that go away. And so what does that ultimately do? Makes it harder for your immune system to get rid of the bad guys. So think about it, all right? How bad is this sneezing and coughing, really? All right, so also important, we'll see in Bio 202 in the formation of stomach acid. So histamine, some of the drugs for indigestion involve histamine. And important as a neurotransmitter where it promotes wakefulness, all right? Again, that's kind of an immune system response. Think about it. If you've been invaded by a virus, well, who knows? Maybe there are more bad things out there. So histamine, in addition to causing, the red eyes and the vasodilation, all that kind of stuff, it kind of promotes your mental alertness so that you can better protect yourself from getting invaded by something else. So antihistamines are antagonists of histamine. So what do? They get rid of the coughing, the sneezing, the itching, the itchy throat, the little tickles in your throat. They help to get rid of the red eyes. And of course the other thing they'll do is they decrease mental alertness or wakefulness. And so what do they do as a side effect? They make you a little bit drowsy, don't they? That's one of the things that happens when you take histamines for your allergies. They make you drowsy. A lot of people try to take some of the antihistamines make you more drowsy than others, and that's what they'll do. Some of the makers of antihistamines will market theirs as the non-drowsy formula. No, they all make you drowsy. It's just a matter of how drowsy they make you, all right? Some are worse than others. So they will decrease your allergy systems, and they also produce drowsiness. And therefore, the people who make drugs, this was a gold mine for them, because look what you can do. So look like in the bottom left corner, Benadryl, I'll bet you've seen it before. It's for allergies, all right? I don't know if you can see, maybe you can zoom in. The active chemical in Benadryl is diphenhydramine. Now, look in the upper right. Nitol, 1 a night. What's the active ingredient? Diphenhydramine. So what you do is you just basically have one giant machine that cranks out diphenhydramine pills, send them down a conveyor belt, and then split them at the very end. Send one into boxes labeled Nitol and send the other branch into boxes labeled Benadryl. Actually, they make them different colors and shapes in order to try to fool you, but you won't be fooled anymore, will you? So, look, you got bad allergy symptoms, you can take a Nitol. It's the same as Benadryl. Trying to get to sleep? Well, you can take a Benadryl. It's the same as Nitol, just in a different box, okay? So, most over-the-counter sleep aids are antihistamines, as well as the allergy. All the allergy pills are antihistamines. All the over-the-counter sleep aids are also antihistamines. They all do the same damn thing, okay? And here's my friend Christina. She was a student of mine back in 2012. She's now been a nurse for a while. She's loving life. And I used to see her at ball games back when Tucson had a baseball team. It's unbelievable. We're the largest city in the United States that doesn't have minor league baseball. But I used to see her there a lot. She's a cool kid. But on Facebook one day she posted this. I may have dipped my nipple in Benadryl for the drive home. She and her husband, she has a couple of kids, and she had a newborn. She and her husband drove to San Diego from Tucson, and they were starting back home again. It was at night. And the newborn kid was a little cranky, and she just thought of, a 6-hour drive with a cranky kid. So what'd she do? Take that bottle of Benadryl, just dip the nipple in there. Kid starts sucking away, and in no time at all, that kid is out cold. So one of the benefits of being a nurse, you know how to do things like that. Or having taken this class, you'll know as well. So. And Christine, believe me, let me tell you, there's a couple of milk bottles right there, aren't there? She actually got breast reduction surgery. She said those things were just so horrible when she would do jumping jacks and stuff. Slap herself in the mouth with them. Okay, so we've covered several different categories of neurotransmitters. We covered acetylcholine, which was with its own category. It's a quaternary amine. Then we looked at the amino acids, and we looked at monoamines. Let's look now at some peptide neurotransmitters. So peptide neurotransmitters are huge. These are as many as 30 amino acids. They're all the neurotransmitters we've seen so far were either individual amino acids or they were monoamines, which are tiny molecules. These are like big giant freight trains by comparison. These are huge neurotransmitters. Substance P. Substance P is the pain neurotransmitter. Now, in fact, P doesn't stand for pain. I forget what it stands for. I've looked it up before. I've forgotten. But in my own head, I think of P for pain. It works, and it'll work for you, too. So, in other words, what happens is, you could cut yourself or bruise yourself or bump your elbow on the table, and you're going, ow! What happens is there is a neuron where you received your injury, and that neuron is releasing substance P at your spinal cord. And substance P activates neurons that go up to the brain, to the pain centers of the brain, and that's when you go, ow, that hurts. So substance P is the pain neurotransmitter. It makes sense. Pain is a very adaptive sense. You have to have pain. If you don't have pain, you're in big trouble. You don't know when something's wrong. There are actually people who are born without pain receptors, and oh my God, they have a terrible life, and many times they don't live very long. They don't know when they break a bone. They don't know if they severely burn themselves. They don't feel it. So pain is a survival sense. You need to know about it, and substance P is the neurotransmitter that lets you know that you're feeling pain. Now, capsaicin, the active compound in chili pepper, stimulates substance P release. And so that's why you see, in hot peppers, when you eat a hot pepper, you get that burning sensation. A lot of what you're feeling is just pain. It's just stimulating substance P neurons to release pain neurotransmitter to release substance P at the spinal cord, activates the pain pathways. They also make some creams now, some topical creams that you can spread on, for minor aches and pains, arthritis, and so on. They've never been totally sure how those work. I've seen some theories that what happens is there's capsaicin in these creams, and when you put the cream on, it like burns when you put it on. And what it does is it causes the release of a lot of substance P, and then the substance P neurons are depleted of neurotransmitter, and it takes them a while to make more, so you get pain relief for a brief amount of time until they can make more substance P. So there's one of your peptides right there, substance P. The other main peptide I want to talk about here are the endorphins, the enkephalins, the dynorphins, and the endomorphins. They block pain pathways in the brain and the spinal cord. So in other words, in many cases, these are neurotransmitters that inhibit substance P. They form axo-axonic synapses, and what they do is that their release inhibits the release of substance P. So therefore, they block pain. And when you look at the words endorphin, endomorphin, that word originally comes from endogenous morphine. In other words, endogenous means inside your body. This was like morphine that you naturally make inside. They weren't discovered until after morphine had already been discovered. So they were named for the fact that they were like morphine, but they were your body's own natural morphine, the endomorphins and the endorphins. Together we call them all endogenous opioids because originally they come from this type of chemical comes from the poppy plant. So there you see a picture of a poppy there, Papaver somniferum, literally in Latin, the sleepy poppy. And what you do is, before the plant flowers, that's a big flower bud on the plant, you make a very light incision all the way around, like do that before you go to sleep, and you wake up the next morning, and there'll be all this stuff that's oozed out. That's opium. That's what opium is. They're called opium poppies, all right? So opium is a natural substance that occurs in nature from which we get all these other things, all right? So agonists of endogenous opioids are the most powerful painkiller drugs by far. These are the big deal pain relievers. And you've heard of all of them, I'm sure. Opium, morphine, codeine, naturally occurring agonists of the endogenous opioids. Diacetylmorphine, heroin, was one of the first synthetic agonists. So diacetylmorphine just means you have a morphine molecule with two acetyl groups stuck on it. So morphine was well known. Again, so opium's been around for many thousands of years. All right, people have smoked opium for thousands of years. It's an Asian plant. If you take opium into the lab and chemically break it breaks apart into morphine and codeine. And then if you take morphine, the thing about morphine is it's a very powerful pain reliever, but it doesn't cross the blood-brain barrier that well. So people on morphine are still in some pain. It makes the pain a lot less, but they're still feeling some pain. The thing is, if you take a morphine molecule and stick two acetyl groups on it, it now really crosses the blood-brain barrier well. So it's a much more powerful pain reliever. And that's what heroin was originally for, and still to this day. Heroin is one of the best pain relievers you could possibly find. It's amazing. Not only does it deal with pain at the spinal cord, which morphine does, but it crosses the blood-brain barrier into the areas of your brain that have to do with the psychological perception of pain. So it kind of makes you not care as much about pain. It's like somebody who's been like in a severe accident. They got like their hand mangled in some sort of industrial machine. And you give them heroin, of course, has been illegal in the United States. There are other more powerful legal drugs than morphine. But you give people drugs like that, and you ask them, how are you doing? And they'll say, well, my hand is not in good shape, but I feel fine. So, or they say, yeah, my hand hurts, but I feel fine about it, all right? In other words, they block pain not only at the level of the signals getting to the brain, but they block the pain pathways inside the brain. And that's a very powerful way to do it. So hydrocodone, which is Vicodin, oxycodone, Percocet, fentanyl, Duragesic, meperidine, Demerol, hydromorphone, Dilaudid, methadone, Dolophine. These are all synthetic agonists of endogenous opioids. So what they do is they bind to receptors. They pretend to be the endorphins, the enkephalins, the dynorphins, the endomorphins. And they are incredibly powerful at it. Now, there's an antagonist for these called naloxone, Narcan sold as. That's an opioid antagonist that's used to reverse opioid overdoses. So when someone ODs on heroin, if you can get to them in time and get them some naloxone, it will block the opioid receptors, and then heroin won't kill them. By the way, how does heroin kill people? Mostly what it does is it suppresses the breathing centers in the brainstem and the pons and the medulla. So people who OD on heroin simply stop breathing. So as long as you can get to them in time, and for a long time those were prescription, but I notice now that at the pharmacies you have to go through paperwork and stuff like that. But if you have someone who's addicted to opioids, you can get Narcan for them. So that if they OD at home, you can treat them right there. Check with your local pharmacist. And by the way, in the upper right corner, picture of the Civil War. Morphine hasn't been around that long. Opium's been around a long time. Morphine relatively recent. In fact, it wasn't really, they weren't able to break it apart separately until shortly before the Civil War. And the Civil War was the first big war where they had morphine to treat soldiers on the battlefield, at least in this country, at least in Western civilization. And what happened was soldiers in the Civil War would get injured, and they would be in agonizing pain. They get some morphine. They go, damn, this really works. And so what happened was, after the Civil War was over, they remembered how good that morphine was. And back then, drugs were not illegal. Up until 1914, you could buy any drug you wanted to. Heroin was sold over the counter at drugstores. So that actually, the Civil War led to a massive opioid addiction in this country. The soldiers, their wives, their families, you had massive opioid addiction, all brought about by the Civil War. See all the good things war does for us. Isn't that awesome? So continuing here with the endogenous opioids. Opioids suppress respiratory centers. That's why they're found in cough syrups. Remember I said that's how heroin addicts die from overdoses. They stop breathing. So the really good cough medications are the ones that have codeine in them. By the way, remember opium is made of morphine and codeine. Morphine is sort of the more for pain. Codeine is more for coughs. So that's why they put codeine in the cough syrups. They also put it in the weak pain relievers. Like remember Percocet and Vicodin were both oxycodone and hydrocodone. Those are codeine derivatives. They're not really all that powerful. It's once you start doing the morphine derivatives that you get the really powerful stuff. But codeine used in a lot of the prescription cough syrups, and again they made them prescription because otherwise people would use codeine cough syrups to get high. All right. Now dextromethorphan is an opioid agonist used in cough syrups that does not cross the blood-brain barrier. So what they were able to do is like with Sudafed. Sudafed, will clear up runny noses, but it doesn't cross the blood-brain barrier. Remember, cocaine will clear up your runny noses. The problem is, it'll do it as well. Problem is that cocaine has powerful psychological effects, and it's addictive, and so on. So the same deal here. You want to get rid of the cough, but you don't want to get addicted to codeine. So dextromethorphan, they designed a drug that's basically like a form of codeine, but it doesn't cross the blood-brain barrier. Okay. Now, opioids also suppress gastric motility. In other words, they slow down digestion. They slow down intestinal contractions. That's why heroin addicts sometimes will go like weeks without pooping. And then actually they get horrible constipation. I don't know if you ever see the movie Train Spotting. That's a great scene in there about that. But that's a well-known phenomenon. Periodically, the heroin addicts will take some laxatives. And boy, when the laxatives kick in, don't get in between them and the bathroom, because they're going to get rid of a couple of weeks' worth there as a result of laxatives. But once again, in terms of drug design, think of what a great deal this was. In the same way that codeine worked on coughs, but you didn't want people to get addicted, so you designed dextromethorphan, works on coughs but doesn't cross the blood-brain barrier. Well, they also designed drugs that work like opioids on the intestines, but don't cross the blood-brain barrier. So Lomotil and Imodium, all right, those are anti-diarrheal opioid agonists that do not cross the blood-brain barrier. And therefore the idea was that you could sell these over the counter and they would be safe. People wouldn't use them as recreational drugs. But of course, did that happen? No, it doesn't. Any pharmacist will tell you the hardcore opioid addicts when they can't get their fix, they'll turn to things like dextromethorphan and Imodium. They don't work very well, but they're better than nothing. It's led to a phenomenon here known as butt chugging. There you go. Over-the-counter cough syrup. Problem is, and I've known, I had a former student who was a heavy dextromethorphan user, and she, the problem is, imagine, cough syrup. Oh my God, isn't that just like disgusting? One spoonful of it, and you're like, oh, whoa, that's plenty. So in order to get high on dextromethorphan, you may have to chug a bottle or two. And imagine your stomach after chugging a bottle or two of cough syrup. Oh my God. So what do the hardcore people do? They put it in the other end. Your rectum is very vascular, so you can absorb drugs there. A lot of suppository drugs. That's what you're doing. You're absorbing through the blood vessels in your rectum. So butt chugging, cough syrup, yeah, great stuff. She didn't do that. She just did it orally, and she finally stopped. Thank God. And if you've never seen this before, you should. There's the world's hottest pepper. It's the Carolina Reaper. Is currently the one that supposedly has the record. Capsaicin can be measured. I think there's a slide coming up on this using the Scoville scale. So anyway, supposedly the world's hottest pepper right now is the Carolina Reaper, which is a form of a habanero. But if you've never seen this before, there's a video where these two high school girls decide to do the Carolina Reaper challenge, which is where you eat a Carolina Reaper pepper and then video yourselves. And if you haven't seen that, you need to watch it. It is absolutely hilarious. So here are just a couple of stills from it. There they go, telling us what they're going to do. They just tried a little bit. Now a couple seconds after that. Yeah, water doesn't work, by the way. It won't help it. Doesn't make it any better. Yeah, gets to this point. Out comes the asthma inhaler. Paramedics get called. She ends up on oxygen in her bedroom. You've got to watch that video. It is absolutely hilarious. So there you go, substance P, capsaicin. There is the Scoville scale. There you can see the Carolina Reaper up there at the top. Notice that jalapenos are not very hot at all. They're way down there. Chiltepines, which are easy to grow. They're a natural plant here in the desert. They're great. Chiltepines up a little higher somewhere there, I think. So, okay, here you go. Which is not an amino acid neurotransmitter. Do you remember all the way back when we were talking about amino acid neurotransmitters? Which one of those is not an amino acid neurotransmitter? That would be norepinephrine. It's a monoamine. We had the two inhibitory amino acids, GABA and glycine. We had the two excitatory amino acids, glutamate and aspartate. Norepinephrine was a monoamine, along with epinephrine, dopamine, serotonin, melatonin, and histamine. All right? Make sure you get these neurotransmitters straight. I expect you to have them straight, all right? There will be questions on quizzes and exams that expect you to be able to tell the difference between the neurotransmitters. So ending up with one here, a couple more, I guess. Very common in popular culture, of course, the endocannabinoids. And I'll bet you already see a root word there you've seen before. So endocannabinoids are neurotransmitters that bind to cannabinoid receptors. And those include anandamide and 2-arachidonyl glycerol, 2-AG. So these are the neurotransmitters that they appear to have effects on appetite, pain, mood, and memory. And ananda, by the way, anandamide, the neurotransmitter, comes from a Sanskrit word meaning joy or bliss. And so endocannabinoid derives from endogenous cannabinoids. So anandamide, those are endogenous cannabinoids. So those mean the ones that you make inside. And of course there's also another substance from outside the body that stimulates these receptors, and that is tetrahydrocannabinol, THC, which is an agonist, and THC is the active component in cannabis, marijuana. All right, so that's what's going on. So think about what happens to people who use marijuana. Go back and look at what the cannabinoids, the endocannabinoids affect. Appetite, pain, mood, and memory. All right, there you go. All right, and laughter. It doesn't say laughter. It should, but typically, people, marijuana users get the munchies. Marijuana now being used, people with their medical marijuana cards for pain and mood, of course. Mood. Marijuana makes you silly and happy and goofy in the head. And long-term users do show some memory deficits. There's mixed evidence on this, but pretty good evidence that heavy-duty long-term users end up with some chronic memory deficits. All right, so cannabidiol, CBD, is a weak agonist of cannabinoid receptors. It doesn't really do enough to get you high, and so that's why you've got all the CBD oil stuff. And it is approved for use in epilepsy, has also been used for pain and depression. Supposedly does not have a lot of the psychoactive effects, so it doesn't really make you high, but that's the stuff that you can get easily. They don't really restrict that. And right now, as I'm doing this, we have Proposition 207 coming up, voting again to see if we're going to make marijuana legal in Arizona. I kind of doubt it. They've tried a few times before. I see on the local neighborhood news groups all kinds of all old people who live up in Sun City. They just think that's the beginning of the end if you make marijuana legal. So they're all going to vote against it, pretty sure. Okay, a few more. So purine or nucleoside neurotransmitters. So in addition to being the body's energy currency, as we've known for a long time, ATP and ADP are actually neurotransmitters. So adenosine, the base molecule, is an inhibitory neurotransmitter. Right? So remember ATP, adenosine triphosphate. So adenosine just by itself is an inhibitory neurotransmitter. Caffeine is an antagonist of adenosine. So think about it. Adenosine is an inhibitory neurotransmitter. So it's kind of, in a way, kind of like GABA, kind of slows the brain down. Not as much, though, not as powerfully. So what does caffeine do? Well, it's an antagonist of adenosine. So since adenosine slows the brain down a little bit, by antagonizing adenosine, you speed the brain up. That's why caffeine is a mild stimulant. Caffeine is nowhere near the level of stimulant that like cocaine and methamphetamine are. I don't care how many cups of coffee you drink. You're not going to get high like you would on cocaine and methamphetamine. You'll just have to pee a lot. Okay? So caffeine is a weak stimulant, and now you should be able to see why. It doesn't directly influence norepinephrine like cocaine, methamphetamine do. Instead, it inhibits adenosine, which is a weak inhibitor. Therefore, caffeine is a weak stimulant. All right. Caffeine, by the way, is one of the most widely used drugs anywhere on planet Earth. All right, everywhere, cultures everywhere. The cola nuts and the betel leaf and things like that, all over the world, people have plants that are high in caffeine, and they use them. Caffeine is one of the most widely used stimulant on the planet. And finally, the last one here, nitric oxide. So nitric oxide is very curious. It's a gas. It acts as a free radical. So it doesn't really have receptors, all right? This is a very unusual neurotransmitter, but there's a lot of research on it. Nitric oxide is turning out to have a lot of effects on things. It modulates a lot of things. It's a powerful neuromodulator. A lot of research on it, a lot of stuff going on with nitric oxide. Doesn't have receptors, again, just diffuses into nearby cells. Gases easily diffuse across phospholipid bilayers. So nitric oxide gets access to any place it wants to go, basically. All right. Interacts with glutamate, AMPA, and NMDA system in the formation of memory. Very important in memory formation. And it's also an important vasodilator. Important role in penile erection. That's why you'll see, like, the ads for, well, no, I guess we can't really go there. In Bio 202, we talk a lot more about this. The effects on the heart, nitric oxide on the heart. So it's sometimes used as a vasodilator for people with, like, angina. And that's why they have to warn people using Viagra, don't use this if you're taking various heart medications, okay? You could get a serious drop in blood pressure, all right? So sildenafil, Viagra, is just an agonist of nitric oxide, rather. So Viagra, take the blue pill. And there you go. Power of Viagra. And that's definitely a place to end this right now.